Hi everyone, in this video, I will discuss examples of material balances involving reactions. I-emphasize ko dito yung mga na-discuss natin na concepts and relationships tulad ng yield, selectivity, conversion, extent of reaction. Okay? So, let's say we have here a reactor and the feed to the reactor is 10 grams of hydrogen and 10 grams of nitrogen. So here we have the reaction, which is the formation of ammonia. Okay? So, ano ang magiging products? Of course, we have ammonia. Okay, so let's write that down. Now, of course, ang i-assume natin ay hindi complete yung reaction or mayroong feed, mayroong component sa feed na excess. So pwede kasing mayroon pa ring nitrogen at mayroon pa ring hydrogen, okay? Na matitira. So nakasulat dito yung reaction natin which is already balanced. Perhaps let's write the molecular weights of each species here. So si hydrogen gas mga around 2.0 let's say. Yung kanyang molecular weight. Si nitrogen gas is 28. And si ammonia is of course 17. Okay. Now, let's calculate the following. Number one, ano yung maximum weight ng ammonia na mapoproduce dito sa ating reaction or sa ating process? Before we even can calculate that, we need to find the following. We need to find the limiting reactant and of course the excess reactant. Now, what will be a good basis? Since given naman na meron kang 10 grams of hydrogen at 10 grams ng nitrogen, so perhaps those values are a good basis. So let's just write it down. So yung basis natin ay yung given na 10 grams ni hydrogen and 10 grams ni nitrogen. Okay, let's probably go first with the limiting reactant, meaning let's find kung ano ang limiting reagent dito sa ating process. Determine the limiting reagent. So paano ba malalaman kung ano yung limiting reagent? So first, kailangan muna natin i-convert yung given na masses or weights ng ating reactant. So for hydrogen, so we have moles of hydrogen. Ilan ba yung nilagay natin sa reactor? We have 10 grams of hydrogen. Okay? But the molecular weight, so let's divide this by the molecular weight, is 2 grams per mole. Therefore, ang moles ni hydrogen ay 5. Okay? Next, let's do it for nitrogen. So si nitrogen, ilan ba? 10 grams din, right? And yung kanyang molecular weight naman ay 28. So you will obtain a value of 0.36 moles. So at this point, alam na natin yung moles ng dalawang reactant. Pero hindi pa natin malalaman dyan from those given or from those calculated values yung limiting reagent natin. So how do we know kung ano yung limiting reagent? So we need to compare doon sa ating stoichiometric relationship. So yung stoichiometric relationship, okay, nung hydrogen tsaka ni nitrogen, okay, or let's say stoichiometric ratio, okay, i-compare natin yan doon sa kung ano yung available ratio. Okay? So, for the ratio of hydrogen to nitrogen, again, looking at the stoichiometry, okay, you are not looking at the given amounts fed, but rather just the stoichiometry. So, ano yung relationship ni hydrogen tsaka si nitrogen? So, balikan natin yung reaction. Ayun, no? For every 3 moles of hydrogen, meron kang 1 mole of nitrogen. So, let's write that down. So, 3:1. Okay? Again, we're using moles here. Now, for the available ratio, kung ano yung finid. actually na finid doon sa reactor. So si hydrogen gas, again, we're after the ratio in moles. Okay, ilan ba yung finid natin na moles ni hydrogen? So yun na-calculate natin kanina. Okay, oops, sorry, I have a mistake here. This should be nitrogen gas. Just fix that. So si hydrogen, ang finid natin ay 5 moles, right? But si nitrogen, we have an available amount of 0.36. Okay, so if you will kind of simplify this ratio, it will become what? 13.89:1. So take a look at these numbers, no? Yung stoichiometric relationship nila, kada tatlong hydrogen, isa lang dapat yung required na nitrogen. Okay? Or pwede mong baliktarin yon, kada isang mole ni nitrogen, tatlo yung kailangan kay hydrogen. Pero yung available nila, okay, is that sumobra, okay? Mas malaki ng di hamak kaysa 3 moles yung amount ni hydrogen dun sa availability, 13.89. Therefore, kung sobra yung hydrogen na yan, we can say that hydrogen is the excess reactant and nitrogen is the limiting reactant. So, again, the limiting reactant is nitrogen and the excess reactant is si hydrogen. Okay? So, yan ang sagot dun sa letter B at letter C natin. Okay, since alam na natin kung ano ang limiting reagent, well, malalaman na natin ngayon kung ano yung sagot sa letter A or yung mass ng ammonia na ma-obtain from the process. Okay, so mass ammonia, okay, equals, gagamitin natin syempre si limiting reactant, okay, which is nitrogen. So ilan ba yung nitrogen natin na finid? Ayun, no? 0.36 moles. 0.36 moles of nitrogen gas, but we are after ammonia, right? So what is the relationship of ammonia with nitrogen gas? So si ammonia kay nitrogen, so ang relationship nila ay 2:1, right? 2 moles of ammonia for every mole of nitrogen gas. So 2:1. Okay? Kaso mas ang kailangan natin, and this mathematical relationship here will give you just the moles. So kailangan na lang convert natin sa mass by simply multiplying with the molecular weight of your ammonia. Okay, so it will give you 12.24 grams. Okay, now you know now the amount of ammonia na ma-obtain from that process, so that's the answer for letter A. Okay, alam na natin yung limiting reactant and excess reactant. Alam natin yung initial amounts ni hydrogen tsaka si nitrogen na ipinasok sa reactor. Pero another good question that we can find here or we can answer here is, gaano kadaming hydrogen kaya ang nagamit lang dun sa process? Kasi di ba, remember, hydrogen gas here in this example is excess. Kung nagpasok ka ng 5 grams, 10 grams rather, ng hydrogen sa loob ng reactor, gaano kadami dun sa 10 grams na yon ang talagang nagamit lang? So let's find that out. Basically, what you just have to do here is to subtract, no? So let's write it this way: mass of, okay, so mass of hydrogen used, diba? 10 grams yung pinasok. I'm sorry. Okay, mass of hydrogen used is, we can actually refer to the stoichiometry of the reaction. Okay, so how? Alam natin yung 0.36, okay, na moles of nitrogen, okay, which is the limiting reactant, right? 0.36 moles of nitrogen. But the relationship is 3:1. So for every 1 mole of nitrogen, 3 moles hydrogen. Okay? So yan yung moles. Tapos converting this to mass, okay? Yung hydrogen natin ay 2, yung kanyang molecular weight. So if you calculate this, you will get 2.16 grams. Okay? Now, yan yung nagamit lang na hydrogen. So 10 grams yung pinasok, 2.16 grams lang daw yung nagamit. So ilan yung sobra? So let's calculate that. Let's try to calculate kung gaano kadami yung sobra. So ito yung, okay, so mass hydrogen excess. Okay, so I'll use the symbol XS, which means excess. So the excess will be what? 10 grams yung pinasok mo, okay, minus 2.16 grams lang yung nagamit. Therefore, ang sobra ay 7.84 grams. Okay, so yan therefore yung amount ni hydrogen at the end of the reaction or of the process. Now, remember I discussed last time paano computein yung percent excess. Okay? So, percent excess is what? So, kung naalala niyo yung formula, moles fed minus moles of moles not theoretical. Okay? Ibig sabihin siya yung kailangan lang divided by moles theoretical times 100. Okay, so tandaan nyo yan. Let me probably highlight that. Okay. Now, again, kapag sinasabi nating percent excess, we only refer to the excess reactant. So, ibig sabihin kay hydrogen lang to. Hydrogen being our excess reactant. Okay? So, paano computein? Ilan ba yung moles na nilagay mo? Moles fed of hydrogen. 5 moles, right? Minus yung theoretical. Okay? Yung nagamit lang na hydrogen, in terms of grams, alam natin 2.16. Okay? Pero kailangan natin dito is moles eh. So, compute mo na lang pabalik kumbaga, or you can just simply use 0.36 times yung 3:1. Diba? This one. If you stop right here, yan yung moles hydrogen used. Okay, and then divided by, kukopyahin mo lang yan, 0.36 times 3:1. And it will give you what percent? So I obtained here 363%. Okay, so ganyan kalaki yung excess ni hydrogen. Okay. And lastly, compute din natin yung tinatawag nating extent of reaction. So kung naalala ninyo, ang extent of reaction ay, let me write the formula. Okay, extent of reaction. So that will be extent of reaction is moles after reaction minus initial moles. Okay, divided by some stoichiometric coefficient. Depende kung ano yung species. Okay? And remember that this portion here, this parameter, meron siyang sign, depende kung reactant siya or product. So if it's positive, product siya. If it's negative, reactant siya. Okay? Now, since isa lang yung reaction natin, isa lang din yung extent of reaction, of course. But how do we compute the extent of reaction? You can actually use any of the species involved in the reaction. So for example, if we would like to use hydrogen, okay? So for hydrogen, ano yung extent of reaction? Okay, extent of reaction for hydrogen, or for the reaction, of course, using hydrogen as the basis, moles of hydrogen na pinasok daw, ilan? Sorry, moles of hydrogen, kasi yung Ni is after the reaction. Okay, so yung kay hydrogen gas after the reaction, may natitirang ilan? 7.84 grams. Kaso kailangan natin dito is moles, right? I-divide na lang natin siya ng kanyang molecular weight. So 7.84 divided by molecular weight niya ay 2. Okay, so yun yung moles after the process. Pero yung initial moles ni hydrogen, di ba, pinasok sa kanya, sa reactor ay 5 moles. Okay? And then, divided by what is the stoichiometric coefficient for hydrogen in the balance reaction. So, balikan natin yung reaction, ha? Okay. So, ito yung reaction. Right? And the coefficient of hydrogen is 3. So, ang isusulat natin sa equation, therefore, ay 3. Pero negative. Kasi, again, hydrogen is a reactant, therefore, the coefficient should be having a negative sign in the equation. So, if you will compute this, bigyan ka ng 0.36. Okay? Na sagot. That is now the extent of reaction, and extent of reaction should have unitless, dapat unitless yung kanyang sagot. Okay, now if we are going to base our extent of reaction kay nitrogen, so ano kayo makukuha natin? Moles of nitrogen after the reaction is 0. Okay? Walang natira kasi limiting reactant siya, na-consume siya, and of course we're assuming here, although kaya sinabi ko na assume muna na 100% conversion. Okay? Na hindi 100% conversion. So, ibig sabihin, probably may matitirang nitrogen, may matitirang hydrogen. But now, sasabihin ko na sa inyo, let's assume na 100% conversion. So malamang ubos yung ating nitrogen. So 0 yung matitira after the reaction. Pero ilan yung pinasok? Diba? 0.36 moles. Divided by yung coefficient niya nitrogen sa reaction ay 1. So negative siya kasi reactant. So ang sagot dito ay 0.36 din. Okay, gaya na sinabi ko, ang extent of reaction isa lang kasi isa lang yung reaction natin. So kailangan pare-parehong yung makuha mong extent of reaction value for any basis that you make, whether it's the reactant, one of the reactants, or the product. So if we are going to make the product as our basis, ammonia, so ang extent of reaction niya, tingnan natin kung ganoon din, pinasok na, or after the reaction, ilan yung ammonia na produce natin? Moles of ammonia after the reaction. So saan nga ba yun? Hanapin natin. 12.24 grams, pero moles ang kailangan. So let's take this one. 0.36 times 2. Para makuha natin yung moles. 0.36 times 2. Okay. Minus ilan yung pinasok na ammonia, di ba wala? Okay. We started only with hydrogen and nitrogen. And divide natin siya dun sa coefficient ng ammonia, dun sa reaction, which is 2, right? Positive kasi product siya. So if you're going to compute this, it will also give you 0.36. Yan ang ating extent of reaction. Okay. Now, again, the assumption here is that the reaction is 100% complete. So I kind of forgot na isulat yun, no? Dapat nilagay ko dito 100% completion. Okay. So kapag 100% completion, ibig sabihin yung limiting reactant natin walang matitira, ubos, right? And it turns out na if you take a look, yung ating extent of reaction is 0.36, di ba? Yan yung ating limit, ating extent of reaction 0.36. It's also the moles of the limiting reactant. Tama? That's the moles of our limiting reactant. So if the reaction is 100% complete, okay, for 100% complete, okay, so let me write that down. It turns out that the moles of the limiting reagent is equal to the excess reactant. Okay, in the next video, we'll explore another example, but with emphasis on other relationships such as yield, selectivity, and conversion.